Welcome to video 23 on the TTb course. This video is from part 5 of the course. In part 5 we introduce a set of TT platforms. We then illustrate how these platforms can be applied in a range of case studies. In this video we consider the development of a controller for a domestic washing machine. The material in this video is based on chapter 23 in the ERES2 book. Please note that the material in this video is a summary of the material that's in chapter 23. The video will make much more sense if you read chapter 23 in the book before you try watching this video. So let's consider what we're trying to achieve here. So this slide shows a context diagram of the washer controller that we're working with. So the context diagram shows the washer controller itself and illustrates the various components, hardware components in this case, that the system is going to interact with. So we have a start switch, a selector dial, a water level sensor, a water temperature sensor. We're controlling a water heater, a water valve, a water pump. We're controlling a door lock. We'll say more about that in a few minutes. We're controlling the drum motor, we're controlling the detergent hatch, and we're controlling some LED indicators. Overall, there's quite a lot going on. So at the beginning of any project like this, we need to begin to consider some of the safety and sometimes security hazards. At the heart of a domestic washing machine, we have a powerful electric motor enclosed in a metal casing. As a normal part of the device operation, the electric motor is used to rotate a heavy metal drum at high speed. Access to this potentially dangerous mechanism is controlled by a door with an electronic locking mechanism. We're going to take this device and we're going to place it in a domestic environment. If this was in a factory, there would be a large number of health and safety considerations to apply. In a domestic environment, we need to consider that there's a significant risk of injury if access to the drum is obtained while the device is rotating. Such injuries could be potentially very severe, including loss of a limb, or even life-threatening, particularly for a small child. So the door lock is, we assume, going to look something like this. We're going to control power to the door lock by means of what's effectively a relay type mechanism. We have the door catch and we have a sensor that allows us to determine whether the door catch is operational or not. We have a key functional safety requirement. This is discussed in more detail in the book chapter, but the key here is that we need to ensure that the door lock is engaged and that the door remains closed at all times while the washing machine is in normal mode. This is clearly a key safety requirement for this design. So what we focus on in this video and in much more detail in the book chapter is the mechanisms that we can use to try and ensure that this is the case. So we want to ensure that if somebody opens the door while the drum is spinning, we detect this and react accordingly. Before that, we want to make sure that the door lock is in place and the door is properly locked to avoid the risk that someone will be able to open the door in the first place. When developing the controller for our domestic washing machine, there are two main international standards that we would need to consider. These are IEC 60335 and IEC 60730. IEC 60730 identifies three different classes of control function that we would need to consider here. So Class A control functions are not intended to be relied upon for the safety of the application. Class B control functions are intended to prevent an appliance from entering an unsafe state. However, failure of the control function will not lead directly to a hazardous situation. Class C control functions are intended to prevent special hazards such as explosion. Failure of such functions could directly cause a hazard in the appliance. So let's just briefly look at the differences here. Class A control functions are not safety related. Class B control functions are intended to prevent an appliance from entering an unsafe state. What Class B functions don't themselves, if a Class B function fails, a device is, for example, not going to explode. In the case of our washing machine, which will be Class B, the failure of the control system that locks the door doesn't in itself mean that someone's going to be injured. If that control system fails and somebody opens the door, then there is a risk of failure, a risk of injury will occur, but it's not automatic. Failure of the door lock mechanism doesn't in itself injure anybody. If it was a Class C control function, the situation would be different. In parts of the world where buildings have central heating systems, quite often those central heating systems are controlled by a gas boiler. If the controller for the gas boiler goes wrong, the gas boiler may explode, and that could blow off, cause an explosion that would blow away part of the house and potentially cause significant injury to people in the vicinity. That would be a Class C control function because failure of the system would directly lead to the explosion. In the case of the washing machine, our function is Class B. As we discussed in the previous video, Appendix 3 of the ERES2 book makes some suggestions for appropriate TT software platforms that can be used to meet the needs of a range of different safety-related systems. In this case, we're looking at a Class B design in compliance with IEC 60730, and there are a range of, in this case, 4 different software platforms that are suggested as possible options we could consider here. In this case, we're looking at a correlator A1 platform, which is the simplest option and which is a common choice in this type of application. So we'll assume that the design team opts for a correlator A1 platform. This would be a common choice for Class B designs of this nature, and many manufacturers of MCUs provide support libraries that could be used in such a design. If you look at the ERES2 book, there's much more detail about this example, including how we could implement the software that's required to create a first prototype. And the Kyle example board here is the target for the first prototype that's described in detail in the ERES2 book. That brings us to the end of this video. Please read Chapter 24 in the ERES2 book before you continue with the course. Thank you for watching.